So we're almost done with block number 3. So now you know also how to make a multiple linear regression model. And this is a really versatile tool because actually you can use MLR as a substitute for ANOVA. If you dummify your variables, you can substitute t-test by using also simple linear regression and so on. So we can say that MLR is a generalization of most of the statistical methods that you learned before, at least for statistical methods for comparing means, for comparing mean effects, okay? Well, MLR has its limitations. Well, first of all, we assume that X values are measured precisely, and then Y errors, the measured errors in Y, they are random and distributed normally. That's why we check normality of residuals, okay? And one important thing is that X variables do not correlate with each other. That's important to account for. And it's important to test if indeed X variables do not correlate with each other, because otherwise you will have what is called a collinearity problem. Let me explain this. Well, first of all, you can see that in this case I have 3 points, and if I make a model based on the 3 points, the more x1 and x2 correlate, the closer these points will be to this line, and therefore the less chance that I can find a good position of this plane. Let me show you also this on the Graster app. In this case, I will not make any introduction, I will just show you the app. So the app calls the MLR and collinearity, right? So in this case, I have actually 2 variables, x1 and x2. You can see the gray model is population model, and the blue model is my sample model, right? And then what I can do, I can actually change the correlation between x and y, x1 and x2 variables. You can see, for example, high correlation. And then you can see that when it's highly correlated, the points between x1 and x2, they line on a straight line. What it means? Well, look, I will take a new sample, and then take a new, and take a new. Look how big the variation of this plane is. Despite the sample size is 30, the variation is quite big, right? If my sample size is smaller, for example 10, it's still doable because 10 points and 3 regression coefficients, it looks fine. But now look how huge the variation is, right? Sometimes you can get really, really crazy regression coefficients, right? So for example, in this case, you can see that it's far away from the real B1, right? So correlation really, really makes your model worse. If I add, for example, a little bit of more fitting error, you can see that it goes really bananas, right? So you can see that sometimes you have negative regression coefficients, right? So therefore, check the correlation between your X variables. At least it should not exceed, let's say, 0.5, 0.4, and then otherwise, if you really have a high correlation between your X variables, you can be in trouble. You cannot trust your model. You cannot interpret it correctly because regression coefficients can be, the variation of regression coefficients around the true ones will be very, very, very large. Okay, so that's the last thing I want to remember, and then probably it's a good idea to go to Graster and play with this app. And then in the next video, we will try to repeat everything that I showed you in this video, just in a more compact session, how to do things in R.